Okay, so in our first couple of talks, we looked at what is data visualization. Today, we'll talk about why we want to perform data visualization. And the reason we want to perform data visualization is what it says here on the title is task abstraction, to take away some of the real detailed part of it and view the task at a higher level. So as usual, the chapter starts with Munzner's The Big Picture. And in this chapter, we're looking at why tools are being used. And there are three ways that a tool can be used. One is to analyze data, two is to search through data, and three is to query data. So when we're talking about finding things, the target is some aspect of the data that's of interest to the viewer. And we may be looking at some high-level targets such as trends, which are high-level characterizations of patterns in the data, outliers, data that don't fit well, or features, which are structures within the data that are of interest. And in terms of attributes, these are specific properties that are visually encoded. We may want to look at a single attribute in order to find its statistical distribution or whether there are some extremes within that attribute. Or we may want to look at many different attributes in order to see if there's similarity or a correlation. And remember, correlation is not causation. And last but not least, we may want to look at attributes to see how they relate to one another in network data or in topologies. Or, if it's spatial data, is there a particular shape that stands out? So why analyze task abstraction? We want to look at tasks abstractly rather than the domain level. So, for example, an epidemiologist studying the spread of a new strain of influenza might initially describe her task as contrast the prognosis of patients who are intubated in the ICU more than 1 month after exposure to patients hospitalized within the first week. While biologists studying immune system response might use language such as see if the results of the tissue samples treated with LL37 match up with the ones without the peptide. Even if you know what all this specialized vocabulary means, it's so hard to think about what these two descriptions have in common because they're using different words, contrast versus match up. If you transform these descriptions using a consistent set of generic terms, then you can spot these two tasks are just two instances of the same things. We're comparing values between two different groups. So it's the same type of task, it's just in different domains and with different vocabulary. So then we can start thinking about the actions of the target, and the same visualization tool might be usable for both problems. It might not, but chances are it might be. And it's also useful to think about who has a goal, the designer or the user. Looking at the big pictures, there are three levels of actions that define user goals. Analyze, are we producing the data or are we consuming it? Search, are we looking for known or unknown targets? And query, does the user need to identify one target, multiple targets, or summarize the data? In regard to the analysis, you're either producing an analysis or consuming it. In terms of search, you should be looking for something specific, for example, sales periodicity, or may just be looking for unknown targets. Hey, what's out there? And then query relates to identifying, comparing, and summarizing data that fit some criteria. So in terms of consuming information, we can break this down into different types of cases depending on where the user wants to do different things. So, the user may want to discover, find new knowledge that was previously not known. For example, finding out housing prices in their area and whether those are going up or down, present that data, use of visualization for succinct communication or information if you're presenting to a board or a business meeting, or enjoy, which is what's pictured here, just casual encounters with visualization. So, what do some of the pictograms in the Chinese language mean? And, that's certainly an enjoyable task. It's, not necessarily that you're completely learning Chinese, but get to learn something about the language. And in terms of producing information, we want to generate new material based upon what we found in the data set. And there are three kinds of goals. Pictured here is annotate. We're going to add additional graphical or textual annotations. Here we basically add annotations that correspond to various events. In terms of the income share of the top 1%, so for example, the Glass-Steagall Act is pictured here over on the right, and you can see what impact that had. The Federal Reserve begins the assault on inflation 1979, driving up unemployment. So you can see the impact that that had at the start of this steep rise here. That's annotation. Record is where you can look at a history and capture, save or capture visualization elements as a persistent artifact. So, here we're going through and we're looking at a history of what we've actually done and be able to maybe annotate that history or to describe that history to produce a visualization for analysis. And then derive is produce new elements based on the existing elements. And so here we're going to transform the data into a new element. So the original data were imports and exports, and we transform those into a trade balance. Search is another task that can be performed, and it requires the user to search for elements of interest with the visualization as a mid-level goal. So lookup is a search where you already know what you're looking for and where it is. Then the search is simply a lookup. That's something we do with bookmarks. Locate is find a known target and an unknown location. So hey, I remember that thing. I want to find it. Where can I locate that particular thing? Browse is when the user doesn't know exactly what they're looking for, but they have a location in mind of where to look for it. And then explore. We don't know exactly what we want, and we're not even sure of the location. But exploration is fun. And in terms of search, there's no better engine out there than Bing, right? And once a target or set of targets for a search has been found, a low-level user goal is to query these targets in one of three scopes. Identify, here we're looking for a single target. If the search returns known targets either by lookup or locate, then identify returns their characteristics. Compare, the scope of compare is multiple targets. We're comparing the two of them, and they're typically more difficult than identify tasks and require more sophisticated idioms to support the user. And finally, summarize is to summarize all the possible targets or provide an overview. And then a target is some aspect of the data that is of interest to the user. So high-level targets are trends and outliers, which are data that don't fit well, and features, which are structures of interest. Targets can also, we can also look at the attributes of the data in terms of targets. Specific properties are visually encoded. So if we're looking at a single attribute, we can find its statistical distribution. Is it normal? Is it Erlang? Is it exponential? And many attributes, we can see correlations, dependencies, or similarities. So rate of inflation and housing prices. We can see if there's a correlation or if those have tracked similarly over the past 18 months. We can also look at network data to know the topology or the layout of the data. And for spatial data, we can look at what is the shape. Is there a pattern that we can find within the shape visually? So the rest of the book is going to be the how section. So every chapter going forward is how, and there are different ways of performing how. They roughly divide into encode, manipulate, facet, and reduce. And we're going to start looking at the hows coming up. Again, thanks so much for watching, and I'll see you in class.